Yeah. Blocking, listening, learning, then, sorry, learning, then, yes, Nirav. Last one,
Forwarding.
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 Okay. Let me discuss one by one. First one is blocking. What do you mean by blocking a state?
To avoid any kind of loop.
First of all, whenever port will come up, it will enter in which state? In blocking state.
Locking.
All switch port will pass through the blocking state to avoid any pre-existing loop. If there is loop exists in the topology, so to avoid that loop, all ports will pass through blocking port to avoid pre-existing loop in the topology. So that's why we have blocking state. Guys, blocking state we cannot forward the user data. Can blocking port send BPDU, STP BPDU? Hello. Can blocking port send STP BPDU? Okay, we will discuss
No,
about
sir.
that. First, let me discuss the all ports. First one is blocking. So as I told you, all switch port will pass through the blocking state to avoid any pre-existing loop. Then a state will be moved in listening state very quickly. In blocking state, port will spend very less time. When port will come up, first it will enter in blocking and quickly it will move in listening state. In listening state, ports will spend some time. How much time it will spend in listening state?
15 seconds.
15 seconds. It will spend 15 seconds over here. 15 seconds. After that, after 15 seconds, ports will move in learning state from listening state. A switch port will start sending BPDU in order to participate in STP election in this state. In listening state, ports will start sending BPDU. Start sending BPDU. BPDU. And in listening state, port can still not send data. Okay, it will send the BPDU, it can receive the BPDU. And blocking, can blocking port receive the BPDU? So answer is yes.
Yes.
Blocking port can receive the BPDU, but it cannot transmit the BPDU. Listening state can transmit as well as receive the BPDU, but listening state cannot forward the data. Fine. In listening state, ports will spend 15 seconds. After that, state will move in learning. So here, election of root bridge, election of root port, designated port, and alternate port will done in this state only. In which state? In listening state. In this state, why switch ports are spending 15 seconds? For spanning tree election only. Whatever election is there, like election of root bridge, election of root port, election of designated port, all election will take place in this place. All election will take place in this state. After that, as I told you, that data forwarding is not possible in this state. So switch port will remain in listening state for 15 seconds. If election is happened, then also it will be there in 15 seconds in this state. After 15 seconds only, port will move in learning state. And in learning state, only DP, only DP and RP port will move in learning state. Alternate port will move in blocking state from here. Let's say a port have got role of alternate. So that port state will move back from listening to blocking. Getting my point? If a port role is DP, that port will move in learning state. If the port role is RP, then also port will move in learning state. Okay. So as I told you, STP election will take place in listening state, and if port role is alternate, then state will back to blocking. If port role is DP or RP, then states will move to learning. Learning state is just for testing the elected DP or and RP is working fine or not. This is the only purpose of learning state. Whatever election take place in a spanning tree, that is working fine or not. So that's why we have learning state. Huh? एक minute.
Thank you.
Thank you. Last state is forwarding state. So forwarding state is the port which is used to transmit or receive user data. And always keep in mind, only RP and DP port will come in forwarding state, only RP and DP port will come in learning state, or all ports can be entered in listening state. Switch port are allowed to send user data in this state, in the forwarding state. Okay, and port will remain in forwarding state until any change will occur. Okay, so if I will give you one overview of all states, so here I can design one topology. Here I can design a topology, one table of STP ports. Blocking, and before blocking still we have one port that is disabled. Disabled means when port is shut down. So blocking, then we have listening, then we have learning, and then we have forwarding. And after that we will talk about some terms like BPDU. We will talk about BPDU here in this section. After that we will talk about the data forwarding, and then we will talk about the MAC address learning. So this is BPDU section. BPDU. After that this is data forwarding, data, and this is MAC learning. This section is for MAC learning. MAC.
Sir, one query, sir.
Yes.
Sir, here you stated the port states that first number is blocking. So, say for example, if the port is up, okay, and it is in blocking state because it is an alternate port. Say for example,
So
then
alternate port will come back from listening state.
no,
Alternate
like say
port
for
will come
initially,
in.
if say
Yeah.
if any port after STP election is in blocking state, sir,
Okay.
then if say for example if there is any kind of a topology change, okay, so
Okay.
then that particular port will also receive blocking port will receive the BPDU, and on the basis of that it will change itself into DP or RP, correct? And
Correct.
then yes. So while it is receiving BPDU and it is like going to change its role, so how much time that will take? Because some documentation show that blocking state
That is
maintains for around
topology
20
change.
seconds.
We are going to understand that in topology change.
Okay,
Don't
okay,
worry.
okay, okay, okay,
Today only we
okay,
will discuss that also. Okay. Don't worry.
okay, okay.
Okay. So here this first port is blocking. Blocking. Then second port is listening. Listening. Then we have learning. and then forwarding. Forwarding. Guys, if I will talk about the blocking port. So blocking port can not send BPDO. Not send, or I am saying S for send BPDO. And receive, it can receive BPDO. BPDO. Okay. It cannot send BPDO, but it can receive BPDO. If I will talk about this state, listening state. So listening state can send
And BPD.
send BPDU as well as receive the BPDU. BPDU. R for receive, S for send. Fine. If I will talk about this port, listening state. So listening state can also send the BPDU as well as it can receive the BPDU. In the same way, forwarding state can also send the BPDU and can receive the BPDU. If I will talk about the data forwarding, so blocking state can not
Sir,
send. Yes.
sir, only switches will generate the BPD, sir.
Yeah.
Because today in our in our organization,
Hmm.
I have connected my laptop to one switch port, sir. There, that time that port was in blocking state, then learning state, then it became blocking state, sir.
After listening state, it will become blocking state.
Yes,
If
sir.
port role is, yes, if port role is, you know, let's say you are running no set command on one interface. First port will pass through blocking state. First of all, this is first state. Blocking state. After that, state will enter quickly. State will enter in listening state. In listening state, port role election will happen, right? STP election will happen. If a port role will, alternate, so that port will again move in blocking state. If port role is RP and DP, then ports will move in next state, that is learning state.
So if we are connecting the system, means it should be DP or DP only, sir.
It should be DP. Okay, you have connected the switch through your computer, right?
Yes, sir.
Oh, this is, I think, not possible, or maybe you are using some software, because through
I,
any software attacker are
uh,
using software. I
in
think.
in Aruba Switch, sir, I also we struggled to find out the loop. Maybe some loop has occurred, sir. We are
Yeah,
working on that. So whenever I connected to my
maybe. I
laptop,
don't think that it is possible. By the way, through application, attackers are using explanatory protocol in Windows operating system or in Linux just to attack in your network. So that's why we have protection. But by default, I don't think so.
We have enabled BPD protection also on every port, sir.
Okay,
Access ports. Even though my system connected port is uh, moving to blacking state. After learning state, it is moving to blacking state. Don't know why.
okay.
And finally, we have removed all the connectivity. Then again, we reconfigured all the switches. Then it became stable.
Okay, how it's possible?
It's
I
not know,
also
sir.
don't know this.
Okay, sir. Okay.
Okay,
Thank you, sir. Yeah.
and blocking state cannot send the data as well as not receive the data. Blocking port is cannot send the data and cannot receive the data. Not receive data. And blocking port can learn MAC address or not? Can blocking port learn MAC address?
Yes, sir.
No, brother. Blocking port cannot learn any MAC address on. the port.
Sir, if it is receiving BPDU,
Yeah,
MAC address also can.
it is receiving BPDU, but it cannot learn the MAC address. Even listening state can also not learn MAC address. Even learning state can also not learn the MAC address. Only
Okay.
forwarding state can learn the MAC address.
Okay. Okay. Sir.
Okay, and data forwarding in this state is possible in listening state. Data forwarding,
No, sir.
no. So data forwarding is not possible over here. Data forwarding is not possible over here as well. And here in forwarding state, only data forwarding can be take place. So we can say yes, 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 it can send the data as well as it can receive the data. Here listening state can also not learn any MAC address. This state can also not learn any MAC address, and forwarding state can learn the MAC address. Yes. This is the small table. You can take one screenshot of it if you want. Fine. Otherwise, I am going to start topology change. This is all about STP states. Is it clear to all? Now, first
Yes,
of
sir.
all, my first question is, if this is clear to everyone, why we need topology change? Why we need topology change? So who will explain why we need topology change in the spanning tree protocol?
We may require additional switches, sir, in
Mm-hmm.
future. We may require any additional switches in future like
No,
already
why
existing network.
topology change is required? Let's say if there is some change in topology, then switches need to inform to root bridge. What is the need of it? Why we have
On the
topology change?
basis of, sir, on the basis of topology change, the switches will start sharing the BPDU, and on the basis of that, they will like create a new logical topology accordingly on the basis of port states, because port state will also change.
So without topology change also it will converge. It can perform re-election. STP can perform re-election, brother. If change will occur, it can perform re-election. And again it will perform maybe root bridge election, root port election, DP election, alternate port election. What is the need of topology change notification? Why notification is required? This is very interesting question, by the way. You know, a spanning tree protocol is height of switching. This is very interesting protocol, and if you want to learn, your all basic concept of switching should be cleared. Like how switch take forwarding decision, what is the MAC aging time, how switch build MAC address table, what is the MAC aging time, what is the MAC aging
Five
time, by
Minutes.
the way?
300.
300
5 minutes.
300.
second.
5 minutes.
Yeah.
300 second, very good. Here I have one topology here in front of you. Are you able to see? We have two computer, PC1 and PC2. Switch 1 will switch 1 will learn MAC address of PC1 on which interface? Question is very simple. Switch 1 will learn MAC address of PC1 on which interface? Hmm?
On Ethernet 0/0, sir.
0/0.
Yeah.
Let's say I have removed PC1 from here and I have connect PC1 to switch number 3. When switch 1 will came to know that I don't need to forward frame for PC1 from this interface. Actually, I think you are not getting my question.
Yes, sir.
Let me
Yes, sir.
ask you again. Just Oh my. There is no entry for PC1 MAC address. Let me generate ICMP traffic again. And now here you can see the entry, right? And if this port will goes down, this switch is removing quickly or not? No. Still, you can see this MAC address is there in table. And after some time it is removing, right? For some time it actually, and you know why it is receiving after some time? Because of notification, because of a spanning tree topology change notification. Otherwise it will remove their mac, this mac address of PC1 from their mac address table after 300 seconds, after mac aging time. So this is the reason why we need topology change notification. Is it clear to everyone why we need topology change notification? If topology change notification is not there, then switch 1 will, even you will remove PC1 from here, switch 1 will have MAC address of PC1 on ETH0/0, ETH0/0. After 300 seconds it will remove the entry. Or if it will receive the traffic with same MAC address on any other ports, then it will remove the entry. Otherwise entry will be there for 300 seconds. Is it clear? This is the reason why we need notification change, topology change notification. This is the reason why we need topology change notification. Okay, is it clear to everyone why we need topology change notification, STP topology change? Because if you will not understand why we need it, then how I can make you understand what is topology change and how many types of topology change are there and how topology change works?
No, sir. My question is, if we
Hmm.
connect only two switches, there is no any PC. Will learn the
Okay,
MAC address, no, sir.
if you have two PC, two
Two
PC
two switches, sir,
switch
without
like
any
this,
without any PC. Two.
without any PC, then you should not run in a spanning tree protocol. Then you should, if you don't have redundancy, then you should not use a spanning tree protocol. And why you will have switches without PC? We are using switch to connect end devices only. Why will have only PC, only switches? Getting Mohan?
Yes, sir. But without any PC, that interface MAC address will learn or not, sir? Each switches, each other.
No, no, it will not learn any MAC address on interface until and unless devices are not connected.
Okay.
Switch have two types of MAC address on interface. First is the interface MAC address, and second one is it is going to learn the MAC address of device which is connected on that port. So we are talking about that MAC address.
Okay. Okay.
Okay. So is it clear why we need topology change notification? Everyone? Fam, Suresh, Nirav, Gokul, Bagish. Clear to everyone?
Yes, sir. Clear, sir. No doubts.
No.
So in brief, like when TCN is there, so switches will send the triggered uh, notification, and on the basis of that, recalculation will happen.
Yeah, that's why switch 1 have removed the MAC address of PC1 after some time from their MAC address table.
Okay. Okay.
Okay, otherwise switch 1 will remove the MAC address of PC1 from their MAC address table after 300 seconds, as you already know. Yes or no?
So the TCN will impact the default storing aging time.
Yes,
Correct.
as in time. Exactly. That's why we need topology change notification. So we have three types of topology change. First one is insignificant topology change. Second one is direct topology change. And for third one is indirect topology change. Guys, insignificant topology change means whenever user interface will goes down or come up, that type of change is known as insignificant topology change. Like in this scenario, as you can see, if this port uh, E0/2 of switch 2 will goes down or maybe come up, or maybe we will connect one new computer with switch 2, so one new port will come up. This type of change is considered as insignificant topology change. Why it is insignificant topology change? Because change take place out of the STP domain. This is my STP domain, yes or no? And whenever user interface means this port, and let's say we have some more port, these port, any change will occur on these port, so that type of change is called insignificant topology change. Because change is occurring out of STP domain, that's why we are saying insignificant change. And whenever insignificant change will occur, what will happen if this port will goes down? See, by default behavior of a spanning tree, first, if there is no any change, then this port is DP, this port is also DP, this port is RP, this port is RP, this port is DP, and this port is alternate. Yes? Yes or no? And root bridge is sending one BPDO after every 2 seconds. It is sending one BPDO after every 2 seconds, and both switches going to relay that. Switch 2 will relay that BPDO to switch number 3, and switch 3 cannot send BPDO from alternate port. As I told you that blocking port, status of this port will be blocking. From blocking port, BPDO cannot be passed. So switch 3 is not going to relay the BPDO which switch 3 is receiving from switch 1. But switch 3 is receiving BPDO on both port, on 0/0 also and 0/1 also. And switches is transmitting BPDO from access port also, from this port also. Right? This is the default behavior. After every 2 seconds, this BPDO will take place here. So root bridge switch will generate one BPDO after every 2 seconds. Fine. And in this BPDO, whatever content we had discussed, I am going to show you as well those content of configuration BPDO. What I am going to do, I am going to capture the link. Let's say this link. I am going to capture E0/0 of switch 1. E0/0 of switch 1. Here is the capturing. What happened? What is this error? Anyone know? Here I am going to configure one IP address on this PC. Here also I am going to configure one IP. Okay. Now this port is in blocking state, right? I am going to down the LAN interface of this switch. But here you know what problem we have. Here we cannot run so MAC address MAC aging. We cannot check MAC aging time. This is the problem here. Okay. So leave. Let's understand the second type of topology change. This is the only concept. Concept is whenever switches will receive TC bits on BPDU, it will set their MAC aging time to 15 second from 300 second. And in insignificant topology change means whenever LAN interface or access port of switch will goes down or come up, that type of topology change is insignificant topology change. Solution of insignificant topology change is port fast. Let me discuss the second type of change, that is direct topology change. Direct topology change is whenever direct topology change means whenever RP port of a switch will goes down, RP port of switch will goes down and alternate port is available. Like in this scenario, if this port will goes down of switch 3. So RP, this is RP port and alternate port is available. Yes, alternate port is available. So if RP port will goes down and alternate port is available, that type of change is called direct topology change. Now see what is direct, what will happen in case of direct topology change. This is my DP, this is my DP, this is my RP, this is my RP, this is my DP, and this is alternate. When this port will goes down, RP port will goes down, switch is not receiving any BPDU on this port, yes or no? Sorry, switch is not transmitting any BPDU from this port. Switch is receiving one BPDU on this port, but that BPDU was inferior BPDU, was not the best BPDU. Switch 3 was receiving best BPDU on this port. That's why this port was superior, this port was RP. But now this port is down, so this port will become what? RP. But it have already one BPDU on this port. This BPDU will expire after 20 seconds. Max age time is 20 seconds. Max age time is 20 seconds. So now switch 3 have one BPDU on this port. This port has goes down, but still switch have one BPDU on that interface. But you know, whenever link will goes down, switch will immediately remove all the learn MAC address from that interface and all the BPDU learn on that interface. It will remove the BPDU as well as all the MAC address which this switch have learned on this port quickly. But this port will take how much time to come in forwarding state? Hello. Whenever RP port of switch 3 will goes down, switch 3 need to send one TCN BPDU to root bridge, but TCN BPDU will send from root port. Now there is no any root port, so this port will become root port because here it is receiving BPDU. Now it is not receiving any BPDU on this port, so now there is no compare. So this port BPDU which switch 3 is receiving on this port will become superior BPDU, but this port needs 30 seconds to come in forwarding state. So after 30 seconds this port will become RP, and when this port will become RP, then switch 3 is going to send one TCN BPDU to root bridge. And after that, root bridge will do what? Root bridge will on TC bit and TC ACK bit in their BPDU. In first BPDU, in first configuration BPDU, it will on both bit, TC bit plus TC ACK bit. But in second configuration BPDU, it will off again the configuration. In the configuration BPDU, it will again off the TC ACK bit. And for 20 seconds it will send TC bit on BPDU. So all switches will set their MAC address table, MAC aging time to 15 seconds, 15 seconds, and 15 seconds. Yes, all switches will set their MAC aging time to 15 second. And how much time topology need to reconverge? 30 second. Yes or no? So whenever direct topology change will occur, then topology need 30 seconds to converge the topology. Getting my point? Is it clear to everyone why 30 seconds is required? 30 seconds is required because alternate port will take 30 seconds to come in forwarding state, and when this port will come in forwarding state, then this switch 3 will send one DPDO. Okay. So whenever direct topology change will occur, then topology need 30 seconds to reconverge. That means for 30 seconds again PC1 cannot ping to PC2. Yes or no?
Yes, sir.
So what is the solution? Solution is uplink fast.
Fast.
So enable uplink fast on switches where alternate port is available. If RP port goes down, alternate port will come in forwarding state quickly. Right? So on switch number 3, alternate port is available. So here we should enable uplink fast, so that whenever RP port will goes down, this alternate port will come in forwarding state quickly. And there is other benefit as well. Let's say switch 3 have 1000 MAC address in their MAC address table. 1000 MAC address. Let's say this switch is connected with another switch on 0/3 port. It have learned 1000 MAC address on 0/3 interface. So if you have enabled the uplink fast on switch number 3, so it will send one dummy frame as well, because switch 1 will remove all the MAC addresses on this particular interface. It have learned 1000 MAC address from switch number 3 on this interface, but it will, whenever this link will goes down, it will remove all the MAC addresses. So if uplink fast is enabled, then from alternate port it will send one dummy frame, and through dummy frame it will share their MAC address table as well. So this is the second benefit of uplink fast. So we have two benefit of uplink fast. Is it clear? And how to enable uplink fast? On switch number 3. For now, if you want to verify the connectivity again from PC1, I am going to send 10,000 packet, and I am going to down switch number 3, which interface RP port, config T, interface E0/0 says shut down. See, it will take how much time? Hello guys, how much time is required to reconvert the topology?
30 seconds.
30 seconds. After 30 seconds, again PC1 can communicate with PC2. So here we have to wait for some time. Fine. Here if you will count the packet, drop packet, so there is 15 drop packet. Okay. And now I am going to do what? I am going to enable, I am again going to run noset command on that port, 0/3 port. Say noset. Again topology need 30 seconds to reconverge, because RP port will come up again, this port will become RP and this port will become alternate. So for 30 seconds again this PC cannot ping. But this time I am going to enable uplink fast feature over here. Spanning tree, uplink fast. So you can see. Now if 0/0 will goes down, interface E0/0 shut down. See. I have enabled which feature? Uplink fast. Now we have reduced some time, but still it is taking some time. We cannot reduce more than this time. So that's why we come up with R spanning tree, rapid spanning tree. Fine, but we have reduced some time with the help of uplink fast. And the last type of topology change is indirect topology change. Whenever RP port of a switch will goes down and alternate port is not available, like RP port and this is DP port. So if this RP port will goes down, so this type of topology change is called indirect topology change, right? And when see this RP port will goes down, this is DP, this is DP, this is RP, this is RP, this is DP, and this is alternate. When RP port of switch 2 will goes down, if this link will goes down, then what will happen? It was receiving superior BPDU over here. Now it is not receiving any BPDU over here. So switch 2 will consider their self as root bridge because it is not receiving any BPDU on this port, right? And this is alternate port, so this port cannot send BPDU, so it is not receiving BPDU over here as well. So switch 2 will consider their self as root bridge, and it will start sending their own BPDU from this interface. It will say, hey, I am root bridge. In this BPDU, root bridge ID will be the bridge ID of switch 2, and sender bridge ID will be also the bridge ID of switch 2. When switch 3 will receive this BPDU on this alternate port, it will compare the BPDU which this switch is receiving on this interface and the BPDU of this interface. Then switch 3 will come to know that switch 2 is not superior BPDU. So means switch 2 is not root bridge. Switch 2 is not root bridge. So what switch 2 will do? Switch 2 will change this interface from alternate to DP, and it will start transmitting superior BPDU from here. It will start transmitting superior BPDU from here. Getting my point? First, when this port will goes down, it will switch 2 will consider their self as designated root bridge, and it will start sending the superior BPDU from this port. When switch 3 will receive BPDU of switch 2, switch 3 will came to know that switch 2 is sending inferior BPDU, so I need to send superior BPDU which I am receiving from switch 1. It will send switch 3 will forward superior BPDU to switch 2, but switch 2 will send superior BPDU from their interface after 20 seconds, after max age time, when the BPDU which it have received from switch 1 will expire. So 20 second, after 20 second it will send this BPDU, and this port need 30 second to come in forwarding state. This port need 30 second to come in forwarding state. So total time to converge the topology whenever indirect topology change will occur is 50 seconds. 30 and 20 total is 50 seconds. Got it? So again, if you want to verify, what we can do, I can generate some ICMP traffic from PC1. Traffic is already going. I am going to down switch to E0/0 interface this time. Interface config T interface E0/0 and say shutdown. This time topology need 50 seconds to reconverge. I think this port is down on switch number 3. Switch number 3 0/0 is down. Switch 3. Yes. Say no shut first to this interface. After that, let me generate. Okay, it's working. Ping is working, and now I am going to down E0/0 of switch 2. Shut down. E0/0 of switch 2 will goes down. I think this path is used between switch 1 and switch 2. One second, let me do one thing. I am going to check switch 3 have learned MAC address of PC1 on which interface. So MAC address table 9B0/1 interface. It have learned this MAC address of this PC1 on this interface. That means definitely there is some problem. First of all, let me check on switch number 2. Interface range E0/0 and E0/1 say no set. Have up the interface. And on switch number 3 also I am going to up the interface. Few interfaces are down. I don't know which interface is down and which interface. E0/0 and E0/1 I am going to run no set command on here also. Fine, ping is working. Now on switch number 2 I am going to down interface E0/0. Say shutdown. So it will take 50 seconds this time to reconvert the topology, right? But here we have the solution of this type of topology change called, what is the solution here? Solution of indirect topology change is backbone fast. Backbone fast should be enabled on every switches. It will reduce 20 seconds of max age timer. Means if backbone fast is enabled on switch 2, then it will, it will discard the BPDU, superior BPDU, which it was receiving from switch 1 quickly. Okay, so you can see here. But in indirect topology change, still if you will configure backbone fast, then also it needs at least 30 seconds to reconvert the topology. On switch number 2, I am going to enable backbone fast. A spanning tree, backbone fast. And now again, I am going to up 0/0 interface, no set. Still you will see it need 30 seconds. So in direct topology change, after enabling the feature also, we need 30 seconds for topology convergence. And these are the reason why we come up with next type of spanning tree protocol, that is RPVST. Because here you can see I have enabled the feature. Still users need to wait for communication. Now ping is working. So if you will count the packet, drop packet, total drop packet is 15. Fine. So this is all about a spanning tree topology change. If now anyone have question,